Hello everyone, welcome to another live stream. Hi there. Hi. Give me a second. Hi, how are you doing? 2 streams in a day, yeah? Yeah. That's the second stream of the day. That's why it's 0.5 at the end of the title. How are you all doing? Hi the Whisperer, hi the Captain, hi the Marius, hi the Comedian, hi. 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 Today we're gonna just keep doing the same thing we done last stream, but this time with a bit more of a shift towards working on the video actually, because I don't think I did that a lot last stream. And for that, we just need to start by rendering some animations, you know how it is. Every number we get really character picture. So, this we have bullet plates. Okay, so first we need to save this as a copy, then we can remove everything outside that we don't care about. Yeah, that seems perfect. And then we can remove the boilerplate, which is basically this. All of this is just boilerplate. And so as such, there we go. Are you gonna add the 0.66 on third stream? Yeah, I've done it in the past. I don't remember which live stream, but there was one day where I just streamed 3 times. Actually, I don't think it was 66. I think it was 75. I think that was the next one. I think I keep dividing by 2. But yeah. There was at least one stream, if my memory does me well, where we actually did 3 streams in a day because I was just having such a good time. When I do more than one stream, that means I'm usually feeling really well or really terrible. Those are the 2 ends of the spectrum. Either really well, I need to put my work, I need to do some work because I'm so good, or really terrible and need a distraction. Hey, that works on me as well. I think it only works on other people. 60, not 60, 50. Yeah, let's not go crazy. Actually, 60 would be better. 60 because then right here we can drop it down a bit, like this. Oh, that's funky looking. That is very funky looking. And then move it out of the way. Oh, that looks very funky. I like it. I like it. Sufficiently funky. We do need to like center it in the frame, which will be a slight bit cool-ish. Not really. Well, I mean, since we're saving as a copy, we might actually as well origin the geometry. That's not what I meant. Delete this. And then there we go. 0. Perfect. And now we've removed the boilerplate. Perfection. Sick, lovely, fantastic. It seems to be rendering just fine. Okay. Run animation. Had unique symbols for 1/2 to the n, for n 1 through 6. That's so oddly specific. Also, like 1/2, 1/4, 1/8. That's curious. All these people that I'm used to, usually there are 15. The stream just begun. It's only been 4 minutes. Give it time. I haven't been streaming in a while. Hi, this time up. Hi. Give me a second. I need to move my microphone a bit. There we go. Now we're cooking gasoline and sick. Okay. I gathered everything. I fixed the Raspberry Pi, by the way. The Pico. It turns out that it was a comically simple fix. Really, truly comically simple. Transfer this one fun fact per stream I join. Alright, just make sure that they are fun facts and not like really sad facts masquerading as fun facts. Hi to someone. Okay. This just keeps going. I need to keep scripting the video and keep working on it. So, basically, here's the point. You can discover if X on the Y on the Z on it. Then the edges are a bit more confusing, but there is a way to just describe them with integers. Oh, by the way, I forgot to use live chat. No one reminded me. So, Mickey, what happened that day when your computer crashed? What do you mean? Well, if my computer crashed, then I suppose what happened that day is my computer crashed. I don't know. What exactly do you mean by that? What happened that day my computer crashed? There we go, we're back. Let's play some music, actually. It's been a while since we played some music on streams. Where's my music folder? That was what happened. What do you mean? What happened? You mean, wait, did you just ask me what happened the day my computer crashed and then answered your own question by saying, oh, my computer crashed? Because I mean, yeah, my computer crashed on the day that my computer crashed. That is what happened. Indeed. There we go. Now we're cooking. I was explaining what caused the crash. Well, I figured it out. Oh yeah, you didn't hear the fix I did. So yeah, basically my computer was crashing a bunch. Like a lot. A lot. And so I was trying to come up with a fix for it. And I did. I think what the problem was that my CPU was getting too high of a voltage. I think that's what was causing the crashes. So I just overclocked my CPU. And it hasn't crashed since, which is the dumbest fix I've ever heard of. But if it works and it's dumb, that means it's just dumb. I'm sorry, what's happening here? Why is it moving like to the side? Wait, what's happening? You are unbelievable. Absolutely unbelievable. Now I need to regen the whole thing. Hi, the ninja. Okay, so this is doing its business. And then... yeah, but there's just a way to describe them with integers. So each... I will need to transform the numbers for the vertices into floating points somehow. It's not easy. Edge would just have a single integer describing them. Next we have the faces, which once again can be described as an integer, and let's finish off. Which means that if we have 3 cubes, oh, we will need to get into a bit more applied computer science in this case. On the very beginning, I might need to actually foreshadow this a bit. Oh, that could be the part of the intro hook, actually. Because this is actually a very interesting problem. The only issue is that you kind of need to understand it really well in order to understand why it's interesting. Where basically you have cache. Okay. We might need to do one real quick chapter at the very beginning, which is types of storage, where we'll have cache, RAM, we'll have cache, RAM, storage, and then bulk. Those will be the four types, because that's usually how it works. Each one is larger, but at the same time slower. Okay. If we have 3 cubes, then each cube could be described perfectly by 8 times 3, 8 vectors. Uh, 8 3D vectors. 1, 2, 3, 4, 12. 12 integers and 6 integers. Now these... I keep thinking, because I haven't planned this video out all that well, because I thought that I would just plan it as I keep going along, and I do it, and that is what I do. The only problem is it's slowing down the process a lot, because the thing is, metadata would work really nicely here, explaining how you need to actually save how many vertices you have as well, and so on and so forth. This would tie in really nicely, however that would open a whole other can of worms, which is a massive pain. And as such, I can't really go too deep into it. Hold on. Just, there we go. Love to watch you walk, make you feel smarter than I'm, it gives loads of the keywords I missed. You're awesome. Glad I can help. Just realized something called boilerplate, which is talking in the future videos. We need to focus on this thing, where right here we create our variable called test. So first, what we want is test. Oh, right, has to be a bit higher up. There we go, and now all we need to do is just prime it like so. There we go, that works. Then assign it the right color. Perfect double. Great, maybe you can just say something and promise to explain in a future video. I mean, yeah, but I mean, I know I can do it, and that's probably what I'll do, but my point is that it would tie in really nicely in with what I'm saying right now. Because right here, what I basically want to do in this scene is like create cubes. So 3 cubes, and then on each vertex have a 3-dimensional vector, on each edge a number or each face number, and then move them into like a single block of just ones and zeros. Just like a block, and that's it. And then I want to move these around and modify them a bit. So, and then after I modify them, the block would change. And that would be like a really cool visual of how you have just ones and zeros, and those ones and zeros actually aren't meaningless. You can read them in some way. And then it will be really... I can actually leave it as a cliffhanger. That would be actually a pretty fun cliffhanger, just on the very beginning, metadata. Yeah, why not? Alright, so this, and then what we need is we need an additional shader, which will be just emission plugged in directly. And the color of emission is going to be this background. And now we're just gonna divide this sucker, separate off the text of the test, and then assign it. And there we go. You could make a list of topics you haven't covered. I already have that list. It has 50 entries, and it's not even complete. Those are just the ones that I just noted down because it would take me such a long time to actually finish them. I already have the list. I need to finish them. I don't need another list. I need to finish the one I've already got. I could actually add like a very, very light volume to it. The reason why is because with a volume, this could actually have a nice little glow. Do we have volume? We don't have volume material yet, alright. There we go. It's very subtle, but it has that glow this time. Because the problem is that this light isn't actually reflecting off the surface. Because that surface that's a color plugged directly to a shader, blah blah blah, long story. The point is, it's just a color, and as such it won't actually be reflecting anything. This, however, will. Yeah, I suppose. Okay, so I think the basic overview of the video will be, right here in memory and addresses, we're jumping a bit too high up, the cubes. Memory and addresses, and then afterwards the next chapter will be actual memory and addresses, which will be the same thing except formalized a bit more. And then foreshadowing, I suppose. I guess that's probably it. That's probably all I'll have time for. On the beginning, we also need to include types of storage. So let's start this video off by talking about types of storage. Hi there, Orion. Hi. Or is it Orion? I don't know, I'm bad with pronouncing. As it. Because even though here I'll divide the kinds of storage into 4 categories, they all function the same way. Yeah, the asterisk are kind of important because I will be ever so slightly oversimplifying the way memory works in this video. I won't be oversimplifying it that much. The thing is, everything I mentioned in this video you could do in C and it will work. However, there are certain things to note about memory. So for example, really often, fun fact, actually, for everyone, a fun fact, you cannot save a single bit. You can only save a byte, which means that if you have a binary number, if you allocate the binary, well, we'll get to that soon, but basically, if you have a binary number, right, so 0, 0, 1, 0, 1, 1, 1, 1, 0, some kind of binary number, you cannot actually save a variable that's 1 bit long. The smallest you can save is 1 byte long, so this. The reason why is because, why not? The inefficient, like, so for example, a Boolean type, which isn't an actual type, but, you know, but it's beloved still. The Boolean type, actually, can only be a 1 or a 0, and that's it. However, when you save the Boolean, then a 0 looks like this, and a 1 looks like this. Actually, no, wait, not like this. Sorry, I got taken away. A 1 looks like this. And those are like the only 2 states that the Boolean would be in. All of this is just wasted space. All of it is just wasted. Like, you could just have these be 1s and 0s, but this is not used. Now, this is a massive inefficiency if you look at it this way. I mean, you have 256 possible combinations and you are basically throwing away 254 of them. You don't care about them. They are completely meaningless. But the reason why it's not a big deal is because the cost of working on single bits instead of bytes would slow everything down so much that there is no point. You would get a marginally large amount, because this looks really impressive, but in reality, if you need a number, use a number. If you need a boolean, you just use 2. And the cost of treating booleans as single bits would be so much to the process that we just don't do it. So this makes sense. However, funny enough, really often when you allocate memory, which is kind of like saving, a bit different but doesn't matter, then you cannot even save a single byte either. You cannot even like allocate just 8 bits. Because that's once again too small, and in reality, if I remember correctly, the smallest amount you can allocate is 1024. I think. Or it was 8096. Something in... No wait, that would be 4096. Something in this area. Is this Python? Not really. Python is a bit oversimplified. I think that's a good way to put it. This is C. All right. Focus on this test, which is a specific binary configuration, and then right here, when I say specific binary configuration, we can just... Oh my goodness, this is always so annoying. There we go. We can just remove this and replace it with a binary as well. So... One 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 0 1 0 1 0. Yup. There we go. Thank goodness I've set up the geometry nodes in such a smart and clever way that I can just do it this way and it works perfectly fine. And then right here, we remove the underlying binary number. Actually, we can move it a bit. We can leave it. That's fine. Python is good, especially VS Code. Well, yeah, Python is good, but it's most human readable and somewhat slower. I wouldn't say that C is harder to get a grasp of, because the reason why I'm starting this computer science series with C is because it's really easy to explain computers using C, whereas it is borderline impossible to do it using Python. You see, when you ask me, what is this variable inside of a computer, I can tell you, it is these exact ones and zeros. That's what it is. If you open up your computer with this program running, if you open it up, if you take out your RAM, well, it would still need to be powered, but if you take it out, if you disassemble it, you will find this configuration of ones and zeros inside. And that's why I really like C. It's great. However, if you do the same thing in Python, that's a different story. If you do the same thing in Python, if you save a number, you're not actually guaranteed that that number will be saved. You have no idea how that number is saved. It will be guaranteed that it will be saved, obviously, but you will have no idea how. No idea where it is, no idea what it is. Isn't variable like some space in memory that the computer points to, like execute doesn't store a number? It does store a number. That's the whole point. You're thinking of pointers, I think, comedian. But yeah, in C, that's the case. But in Python, not necessarily. The best example of that is the fact that Python, the way Python can handle really large numbers, if I remember correctly, is that it treats them as strings. Which is, let's just say, way different from the normal type of storage for numbers. I'm pretty certain it also does normal type of storage because the normal storage is very efficient, but at the same time, for large numbers, for example, it switches, and so on and so forth. So basically, C explains how computers work really well, whilst Python abstracts it to the point where it's kind of hard to understand. Think about it like the difference between chemistry and alchemy. C is kind of like chemistry. Python is kind of like alchemy. So in C, you know exactly what happens, why it happens. In Python, it's much easier, but you don't know why things work exactly. That's the basic idea. Okay, so back to the script that was scripting. With some asterisks attached. They all just store binary numbers, which explained last video, and the medium for storing numbers 2 videos ago. So if you open up all 4 kinds of storage, so if you... There's a dog screaming outside my apartment. Oh, don't tell me someone got a dog in my place. That would be so annoying. Did you start learning programming, blended math and science? Well, I never really started learning it, I just used it and learned through that. So C has many exceptions, that's another point. The opposite. C has no exceptions. Funny enough, let me show you something that I find pretty cool. C list of keywords. Right here you have a list of all the keywords in C. That's all of them. That's the entire programming language. All the keywords you would ever use. Some of them are extremely niche. For example, register, volatile. Union I have seen, but volatile, register, those are pretty rare. Enum, I guess. Extern and static are kind of used, but though only people who like live isolated in a tower use them. Only use Python and JavaScript. Yeah, Python and JavaScript are really abstract, which basically means that they are, as I mentioned, they're more like alchemy. That's a pretty good way to think about it, I think. So when you save a number in JavaScript, you don't know what it is. You know that it's saved, you trust JavaScript that it saved the number, but you don't know what it is. In C, you know exactly. Yup, this... Okay, great. Rendered, what's next? Variable as type char. There we go. Char. I feel like the test was actually too large in this case if I needed to make everything else smaller, apparently. Program. Yes, but they are popular. Well, I mean, okay. Python is popular because it deserves it. Python deserves the popularity. Python is great. JavaScript, that's rough. That's a bit more tough to say. JavaScript is kind of... how should I put this? Marketed. There was huge money going into JavaScript. Like really huge money. And in this case, I don't mean like a shadowy cabal or something. No, the amount of optimization that JavaScript got is insane. And basically, in my personal opinion, I think that Python deserves the popularity because Python is great. Everything works with Python. But JavaScript was kind of forced with compatibility because of the way internet functions. JavaScript is popular because no one wants to be khaki PHP pant wearer. I refuse to believe that there are only two options in this day and age. I don't mean to be that guy, but I do mean to be that guy. And backend in Python is not only already exists, but has existed for a while and works great. Wanna know how I know that backend in Python works great? I have a website that runs on it. WebAssembly is an option. WebAssembly, oh, I've seen WebAssembly used a bunch. I have no idea how WebAssembly works. I don't like WebDev. But I refuse to believe that there are only two options. Must be more. Why can't we do it in Python? Why can't Python also handle that? I do not like WebDev either. No one likes WebDev. WebDev is a necessary evil. WebDev is what happens when something incredibly useful is also incredibly boring. Hi, the void. Backend dev. Oh, yeah, I mean, that's what I'm saying. Like, frontend. Also, once again, how could you tell I don't like frontend? No, it's real diagnostic elements for clients. Yeah, I get that. I should make this better though. I've been saying that for months. Eventually I will, probably. Eventually I will make it. Hi, the void, hi. I was always amused that you get introduction to imaginary numbers in computers before math and calculus and physics before maths. Really? Imaginary numbers in computer science? I don't know. I've never taken a computer science course, so I wouldn't know. What I really like about these videos is that I don't need to research much online. I don't need to read like textbooks and stuff. Because if I want to see if something works the way I think it works, I can just run it. Right here I'm trying to make the point that the actual value is stored inside and all that matters is the way we read it, and there we go. I'm storing the value and I'm just reading it in different ways. Simple. Well, to be fair, right here I'm casting, but unrelated, long story. Can I make a website for free if only Python without having a server? I do believe so. There are plenty of free ways to host websites. Like Cloudflare is an example, but also GitHub. GitHub is, I do believe, the most common one people do. When they need to host something small. I don't know if that's free though. I think it's free. I wouldn't know. I have a domain and a server. But anyhow. There you go. Have a number like 15. You can note it down in binary, and all of these number the same way. Size and speed. Basically, the more to the right you go, the Can I make a strong website without the need hardware? Well, you will need some kind of hardware. The only question is, will you have to pay for it? Obviously, Scratch wipes the flow of any other language is goated. Okay. This appears to be rendered. Perfect. I don't like the fact that that was a black screen, because that's usually a symptom of the fact that my graphics card's about to crash, which would suck, certainly, a fair bit. Whoops. Then right here we print that variable, reading it as a number. Oh gosh, oh golly. This will be a bit tricky. Print that variable, reading it as a number. Why is %d, by the way, an integer? I don't remember. There was a reason. %u, if I remember correctly, was unsigned. Oh, I think. That made sense. I don't remember why %d. Does %i stand for something different? Decimal? Oh, yeah, x is hex. Wait, that's... hold on, never mind, I take it back. X is hex? Hold on. C print a hex number. Oh, thank you. I'm glad that you value my privacy, but no, H. Wait. No, it is X. Naming conventions always are so close to making sense. Wait, what am I doing? I blacked out for a second again. On one hand, I really want to drink more coffee. On the other hand, I'm going to sleep soon. I have a full cup right next to me. I could drink it and pull an all-nighter. Decisions. The indecision is killing me. Okay. Print that variable, reading it as numbers. So first we need the print text to appear. Print. Ooh, I see the problem. The space between them is the problem. Oops. I don't have the patience to lay down the characters separately, so I'm just gonna move it in the middle. The way a load and save intended. There we go, print. And then number. And this one is too large this time, huh? That's great. I'm glad this time it's too large for a change. Okay, now what we need to happen is we want this right here, this line, to vanish all except for the %d. %d gets a pass. There we go. Okay. Let's keep going. Nажать left to hide the speed. Hi, Nothing Place. Hi, welcome. Some asked, we need to about per second kind of reading speed. We do want to be low. Sort of interruption, but is it always this lonely? What do you mean always this lonely? That's... ouch! Ouch! Words can hurt, you know? Sticks and stones may break my bones, but I have feelings. That's why I can't do this sober. Yeah. Just script writing. I'm working, alright? I'm trying to be productive. Compromise. The division comes from the cache is the hyper fast side of CPUs. I love some L1 cache, yeah. I'm not even mentioning the L1, L2, L3 and all the other jazz. Also, I'm not mentioning the difference between, because like the entire thing, I will need to chuck in so many asterisks into this, which is so annoying. Because I blame computer scientists, by the way. When I make videos about physics, when I make videos about physics or chemistry, I also oversimplify. I also don't mention everything, okay? Sometimes I just chuck in classical mechanics equations, and no one in the comments is bitching about me not including the relativistic version, because the classical equation is actually losing its accuracy at speeds that are close to the speed of light. But with computer science, I'm gonna say that all of these store the value the same way, and I guarantee you, there will be someone in the comment that will be like, actually, when it comes to storage, the HDD drives and SD, no one asked! I am fine. I'm fine. I'm fine. I'm okay. I don't want to over-explain every single detail. That's not on me. You will see it, Catman. There will be so many... Stack Overflow, alright? That's all I need to say. It goes vary depending on CPU architecture as well. I mean, yeah, that's the whole point of a CPU. Of course it varies depending on the architecture. Can't ever pick a single one. I'm not gonna come on. Ah, actually, RISC-V architecture, ... I mean... I mean, no way... each day, there's really dedication for it. Yeah, dedication, insanity, desperation, whatever you want to call it. There's a bunch of D words there. The insanity isn't D word, but you know what? It's fine. This, there we go. Finished. What's next? Reading as a number, which means right here what we want is we want an additional text. That's going to 60. Person D, and we want this person D to be there. We go. What's wrong with you? Just select the thing. All right, and then the other side. Test. There we go. Perfect. Thanks for encoding. I mean, yeah, of course. There's the third episode of the series. Alrighty then. There we have it. Render. No, what's percent? Different. Wait, that's a different. Oh, I'm in types. I'm in the wrong place. Yeah, right. Oh my goodness, this one. The cache is the hyper-fast storage inside the CPUs that can just I mean, okay, memory. The more forward we go with technology, the more problematic actually all this becomes, because with the PCI M2, the storage is also fast, okay? Storage is already an extremely fast way to store things. Just wait until you start describing humor of RAM as well. Actually, what is the average RAM reading and writing speed? I'm curious. So DDR5, I think, is the newest one. RAM reading and writing speed. Non-uniform memory access. No, I ain't doing that. Because of the physical proximity to the CPU. I suppose that is true with stuff like these, but I'm trying to get a guesstimate. Okay, effective memory bandwidth. I'm guessing that just means reading writing speed, because I'm honestly too tired to actually read into it. $69 gigabytes per second, right? Per CPU core. Do you have a website? Yeah, I do have a website. It's only there to keep track of donations, though. The problem with the end is so that makes me have of these tables. Per core. Okay, I don't actually care about this, do I? Short answer. To improve our customer experience, next gen application workers are becoming more complex. Like it's needs to be more cores, but of course, account increase DDR4 memory bandwidth per CPU car has declined. Okay, so DDR5. Okay, so the breakthrough of DDR5 is the per core, not the bulk. Okay, that makes sense. But still, DDR5 gives you 69 gigabytes per second. I know that it's an unfair comparison, considering how, as I just read, RAM is about much more than that, but PCI M2 reading writing speed. And there's an excellent kind of piece, the fact you can reply to each and every message. I think you shouldn't take that lonely thing the wrong way. You wanna know something funny, Nothing Place? I spent the first 200 live streams, over 200, with an average viewership of less than one person. Most of the time there was no one watching. 200 days in a row. Having 15 people is a crowd. We value privacy. Yeah, sure you do. Hold on. Reading writing speed. Decent reader fees from M2 SSD. Wait, what? Hold on. Am I the crazy one or am I being gaslit? Am I crazy or gaslit in this case? Because there are no units. That far, but what? Okay, PCI M2. Legacy data express. This says gigabits per second, the other one doesn't. They're trying to hide that information from me. Pure dedication, surely grow vast with such dedication. Yeah, I kind of gave up on that nothing plays, honestly. You know what, after lying to myself that I will grow quickly with that kind of dedication for the past 2 years, I kind of gave up. The HCI controller on that image. The PTSD. This? Looking just for the information, form factors and keying. I ain't gonna get the information, will I? I could just check what they... Well, no, I can't just check what the interface can handle, because the interface will obviously be able to handle more. You know what? No. Listen, I am too tired to be coherent, so we're just gonna leave that tangent be, and we're gonna keep going, keep pushing forward. Being tired is a mindset. One I don't subscribe to. Final variable says, which is binary configuration, variable chart, right? You can read as a number, then as a number, then reading as a character, then reading as a number again, but this time being unsigned. Okay, so here we just want to do 700. I want to copy them lower down. This time this a bit further. And this time this person C. And this time 1, 2, 3. Move all of these forward. 1, 2, 3, 4. Move all of these forward. Bison is on a bunch of hotels. My first job, my goodness. You know he's a tracker. He starts reading Wikipedia articles, yeah. Hi to like and hi. It's very... Not many people are gonna get that reference. Only the true livestream watchers understand the impact of all piss. Okay. Memory is really fast. Let's throw images and videos. Just the values. And then finally storage, which can store anything, but the reason why I separated it off into non-bulk and the bulk is with storage in a single device, or you can have it as a theoretically infinite network of devices. This is not stored anymore since it's effectively point-based. which is always pretty fast. It's the writes that gets you. I'll be honest, I don't know exactly how SSDs work. SSDs work. Am I having a stroke? RAM is fast, but also it's also slow. I mean, no, it is fast. RAM is just fast. That's the point of RAM. It's just slower than cache, which I mean makes sense. Versus that block versus object versus file. Well, yeah, that's why I'm in this case separating it into bulk and storage. I think that is a fair bit of separation as well. Bulk is sort of where you stop caring about the speed. that's how I draw the division. Cache if it's inside of a processor. RAM is if it's random access memory. Storage if it's storing permanently. And bulk is if you don't care about the speed. That's bulk. That's my very scientific division of memory. You're welcome, you can use it. But the point still stands. Saving a number in cache is the same as saving it in storage. With once again an asterisk, because it's actually not, because the ways of storing are different. For example, malloc versus saving it as a file. Once again, the freaking nerds. It's not gonna be fun. I tried to catch your previous stream, but I was too stoned to stay awake. Fair reason. Although, you know what? Not watching my streams, I feel like my streams would go hard when you're stoned. I'm just saying. You know what's funny? It just hit me. It just hit me that actually I am going over memory and storage before I'm getting over computation. I haven't mentioned registers yet. I could actually introduce it in the next video as like the even faster, because I guess cache isn't the fastest method of storage. The fastest one is a register. You can store a whole number on it. A whole one number. That's pretty powerful. Improve again the storage type and some other things like no, I'm not. I don't want to go into the specific stuff because I hate it. What I want to do is see. That's what I want to do. The entire reason why I'm doing this series is because eventually every single video will have its own code to it. Every single video will go parallel to a piece of code. Whatever I do with C, I'll just make a video about it. The problem is I first need to explain the context for it so that everyone would at least understand. Also, in this video, I kind of wanted to explain like pointers from the perspective of having them as operations. So just like you have addition, multiplication, and or not, you could also have a pointer. But I think I will need to leave that for the next video. Okay. We'll go over that. The ways to use it. But first, we need the date types. So what are they? And then at the end, I'm gonna go with because this, now that we have that chapter there, this can function as a nice a segue. This gives the context for a segue into why reading things is important, because you can't, like, here's the thing. The predicament is that you want your CPU to have the data. However, your CPU isn't big enough to have the data. So what you do, like, the interesting part of this video will be that you have your CPU, you want to have the data, but it's not big enough to have the data, so you put that data into RAM. But then the question becomes, how do you read that data from RAM, knowing that then your CPU has to remember where it is in RAM? And hence why the system of pointers and offsets, which basically allows you to do it. Because otherwise, if you have an image, made of some X amount of pixels, then if you want to display it, let's say you have integrated graphics you're doing with the CPU, you want to display that image on your monitor screen, the entire image, let's say, cannot fit into the CPU. So instead you save the image into RAM, but then you still need the CPU to know where those pixels are. And if for each pixel you just have an associated number that tells the CPU where it is, that would not only not help, that would be actively harmful. If, however, you do it with pointers and offsets, it works perfectly fine. It's actually really efficient. That's the point of the video. Finally, I got here. I'm sorry, but I'm a bit sleepy right now, so I do apologize if I keep blabbering on and just ranting, but oh, this is what it is. The points improved. Okay. Here's number again. This time, number being unassigned. More correctly, some things aren't always connected to memory as well, but all over the place. Yeah, but I'm not gonna... Class? No, I hate classes. Classes don't exist, Quasar, okay? Classes are not the real thing. So don't use that name when you're speaking, okay? That is my Voldemort. Classes do not exist. The reason why classes don't exist is because there are no classes in C. There are classes in C++, however, the only reason why classes exist in C++ is so that when you have some C++ code, you cannot just compile it into C, okay? That's the only reason why classes exist. Big abstraction invented classes to stop C programmers from enjoying life. My goodness. For a simulation video, I wanted to use the OLC Pixel game engine, which is just like a graphical engine written in C++. And the way I was planning to do it is I would just simulate stuff in C, and then have the graphical engine in C++, and I would just compile both of them with GCC. But no, you can't do that, because the game engine has classes inside, and like, yeah, you can totally like work with classes in C, because C can work with anything, but you cannot compile with them. What am I supposed to do? Compile this into an object file, and then basically compile with the object file without a header, because the header has classes. Classes shouldn't exist, just like setting your values to constant. That shouldn't be a thing. Both of these shouldn't exist, and they're just mistakes. They were added on accident. No one realized. Boy, I have some strong opinion about classes. Bless me. There we go. Perfect. Bless you. Thank you, Misty. Thank you. What's the difference between a half adder and a full adder? Full adder is just half adder with the other half. kind of it, honestly. A half adder is basically looks like this, where you add two numbers. and a full adder is basically this. The reason why is because right here you add two separate numbers, whilst, so like this, two separate numbers, but you output a single full number, which means with a half adder you get 0 plus 0 is equal to 0, 0, 0 plus 1 is equal to 0, 1, 1 plus 0 is equal to 0, 1, and 1 plus 1 is equal to 1, 0. So you can see that that these two will never give you a 1, 1. They will never give you 1, 1. That's why it's a half adder, because of that inefficiency. And basically, if you want it to not be inefficient, then you need to add 3 numbers. So the same deal applies, except the only difference is 1 plus 1 plus 1 is equal to 1, 1. That's how we know done 3 in binary. Watch my video about binary numbers if you wonder why. And the reason why this is useful is because then once you have this, then you can basically... I forgot that this was a thing. Then you can basically like chain them together like this, and from that you can create any bit adder. From a full adder you can just chain them together and add however many bits you want. Hope my explanation was sufficient. Okay, now what now? What now make it? Oh, this rendered egg. Oh no, never mind. Still going. Only halfway there. Okay. By 8 3D vectors, 16 inches. Can all be represented using a binary number. How do I convert a float back into... How do I convert a float back into a binary representation of a float? So let's say I have a floating point number and I want to get back from it the like logic for each bit. How would I do it? Because I know the equation one way. Okay. Hold on. That's a genuine question, by the way, I think I asked, because this equation tells us one way with what we want to do, right? We can just do the thing. But what about the other way? Because basically the way I'd like to do it is I would like to have an equation. Effectively, here's what I would like. I would like to have an equation which takes in a function function which takes in a number f. No, that's confusing. A function that takes in the number f and returns 1 f and bit number, and returns 1 if something, and returns a 0 if something. The bit number we obviously would divide into 2 because the sign is obvious, but the bit number would obviously divide into 2, the exponent and the basis. Okay. How would I do this? That's a good question. Because the tricky bit is that what I'm basically looking for is really complicated. Yeah, I don't have the brain capacity for it right now. An algorithm for coding a double precision or a floating point number. How do you encode like a number though into it? Is there a way? Can you even? Would I'd imagine you can. Compilers do it. Yeah. Anyone got any suggestions? Anything? What's the goal again? The goal is to create some kind of algorithm or function, well, preferably a function, which takes in a number, f, and gives us back, like, the binary representation in as a floating point number. So basically, we want to take a number f, and for this equation at the top, we want to figure out what is the every single one of the b's and every single one of the e's. Or at least, what's the closest configuration that would work for it? I could, I guess, implement like an algorithm for looking for it, where basically each time... Huh. I don't know, it's tricky. Yeah, each time, because getting the number back is easy, okay? So what I could do is I could just keep increasing the number until I either get it equal to the number I'm looking for, or I overshoot it. Or actually, I can use a compare node, which gets like a similar one. And then, that's such a dumb way to do it, my goodness. That's a terrible way to do it. But I mean, it would work. Okay, I think that's the way we're gonna do it. I'm gonna leave it for tomorrow, make it to actually implement. Yeah. Write something in Python. See, the problem is I won't really be able to use Python for this. If I could use Python, it wouldn't. If I could use Python, then I would just plug C into it, and C would take care of me. I could just, like, if we could do it using Python, that's a solved problem. Because in Python, all we would have to do is just write a program in C that takes in a floating point number and output it with like a 0b. And there we go. Fixed, finished, congrats. And then in Python, run that program. The only problem is I won't really be able to do it using a programming language, and I'll have to do it in geometry nodes, which means I'll have to do mathematics. In C++. In C and C++ is trivial because that's not difficult at all. The problem is doing it without the programming, basically. Yeah, but I think that will work actually. Just the loop that will zone in onto the number. Yes, that should be fine. This will basically be like a sorting algorithm, except it's more inefficient. Just that. All right, future make it. I know you're gonna hate me for it, but that's what you'll have to do. Using a binary number. Like this. Now if we wanted to store... Hydershot, hi. My application still isn't posted yet. I'm getting impatient and paranoid. Have you looked up online how long it normally takes to process an application? Because maybe it's normal. Oh. To kill something, you first need to have it. Damn, that's rough. Also, it's in between. In 12 days since I submitted, and so hopefully in the coming week it'll be done. 12 days isn't too long. That could still be getting processed. That makes sense. I'm getting really tired. You know what, everyone, we might need to end the stream because I'm having more and more trouble thinking and more trouble formulating sentences, and it shows. It shows. Yeah, I should probably go to sleep. I've just been getting a little bit of a panic attack, so I thought streaming would be a great way to solve it. And believe it or not, it worked. Alright, move this bit to the right, add a space, perfection. Now you will need this color right here, and then you onto the other side will need this color. And you will need this color in the middle. There we go. Now we can set the entire thing to just be this material. And we basically moved the code into 3D. Which, well, sure is something. Certainly. What time is it for you? Oh, it's not late. I don't operate on European time zones anyway. Alright everyone, well I'm glad you could join me on this fun adventure of not doing much. Actually, we just did a single animation string. Jeez, I'm so behind. It's fine though, tomorrow it should be a more fun of a live stream and it should last longer because I'll probably be well rested. And for now, I suppose that'll be it. Thank you everyone so much for watching and have a great day. Bye.